Welcome to an introductory course on Arduino. So in this course, we will talk about Arduino softwares and how will we create some projects based on Arduino platform. Especially we are focusing on Arduino Uno board and Arduino IDE software in this video session. Let's get started. So while talking about Arduino, so Arduino is an open source Microsoft microcontroller based development board. So it is basically open source both in terms of hardware as well as in software. So we can use this Arduino to read some sensors and to control something like motors, lights. These are the basic operations we are doing with Arduino. Apart from that, we can say that the ability to upload programs to this board which can interact with the real world things. So that's what we called Arduino. We will use further for Internet of Things purpose, and we see that this kind of Arduino board can be used for different home automation and some industrial automation as well. So basically, if there is something that is in any way controlled by electricity, Arduino can be interact with it in some manner. So this is the main advantage of this board. So we can say you can make devices which respond and react to the world at large by using these kinds of boards. So I have done my level best to give a basic overview of the fundamental skills and knowledge that you need to get Arduino up and running. So the possibility of Arduino is almost infinite, and there is no one tutorial which will cover all the areas of Arduino. So getting some basics on this particular domain, and we should need to do something out of box, and this is the way to explore things. So before we get into Arduino, we should know first what is a microcontroller. So microcontrollers are small integrated chips, and basically these integrated chips consist of the main part called a processor, and which is followed by some flash memory for the storage of programs, and we can see some input output peripherals as well. And one of the most important thing that included in this particular integrated chip is the RAM, random access memory, for processing, storage and processing. And there are some other peripherals such as clocks, and that is produced by the crystal oscillators, and timers and PWM are the other peripherals which is attached to the integrated chip called a microcontroller. Now the $1,000,000 question is that what is the difference between a microcontroller and a microprocessor? So microprocessors are designed and used for general purpose applications, while microcontrollers are self-sufficient and used for some specific tasks. So let me take some examples for the microcontrollers. So you can take a refrigerator, which is normally seen in all the homes, and apart from that we can take a washing machine. So all these electronic equipments which consist of some circuit board as well as some integrated chip embedded on it. So these can able to do some specific stacks which is designed by the manufacturers. So this microcontroller base these devices, we call it as an embedded system which is doing some specific task only. I think now you understand what is the difference between a microprocessors and a microcontrollers. Now just get into the Arduino. So as I told you before, Arduino is an open source physical computing platform, and it is a small microcontroller board with a USB plug, so which is very easy to interface with any systems. So, and I need to say that the basic heart controller which is implemented inside this Arduino board is Atmel 326P. And one of the important thing that is quite the reason for the advancement in this technology era is that it is very easy to use hardware and where the software as well, because today if we are going to use any any uh, ARM based processors or any other Freescale based boards, we should know some hardcore programming skills like embedded C, so which is very much tough. And if you are going to directly interface with any existing controllers like PIC 16F877A, which is a middle family of PIC microcontrollers, or Motorola microcontrollers, or ARM based microcontrollers, we should know the basic kind of architecture in order to do something on this board. But if you are using Arduino, so there is no need of learning some basic architecture or something. You just go through the basic layout and you can able to interface some components, and using the Arduino IDE software you can able to code it and the prototype is ready for use. So this is the beauty of Arduino. So it is programmed in Arduino programming language. We can say APL, Arduino programming language, which is very much equal to C and C++ programming. So I think all the engineering students, they will have some knowledge. I think from the plus two onwards, you are learning some basic concept of C. So with this, we can able to do Arduino programming very easily. And the another one of the important factors is that the way more easy to program compared to other microcontroller packages. As I told you, if you are going to use any ARM based or Texas based boards, you should know hardcore embedded C programming skills. So this is not required when you are starting with an Arduino. Now let's talk about what are the flavors of Arduino boards that is available in the market right now. So we will discuss one by one. So first one is nothing but Arduino Uno board. So this is the trademark of the Arduino, which give greater popularity in the industry. So this is the basic Arduino board, and we have nearly 5 pins. We will discuss the internal structures and the pin layouts of this particular board later, because we are going to use this board for the throughout the courses for doing different projects. So we will discuss it later. Let's move on to the next board. So this is basic Arduino Leonardo board, which is quite similar to your existing Arduino Uno board. So some difference will be there in terms of the basic pins available, as well as the capability of the program like flash memory and other processing capabilities. And other one which is available is Arduino Mega board, so which is quite popular as compared to Arduino Uno board. This particular Arduino Mega board have greater processing capability, and specifically you have many number of analog pins as well as many number of digital pin, which will give the ability to interface more number of sensors as compared to an Arduino board. If there is a 10 number of or more than 5 number of analog sensors you need to interface with, so you cannot use an Arduino Uno board, because which is basically having only 5 5, I think 0 to 5, that is generally 6 analog pins are available. So you should go for something else, otherwise you need to use multiple Arduino Uno boards. So the single option is available is you can directly use Arduino Mega board, so which will support nearly 10 to 15 analog pins, as well as nearly 20, about 20 and digital pins are available. So which is great thing, and the kind of processor which is imprinted inside the Arduino Mega board is quite more efficient than your Arduino board. Let's get into the next processor, microcontroller based board, which is a variant of Arduino, that is an Arduino Nano board. So in the diagram itself, you can able to see that there are a minimum number of digital pins as and nearly 7 analog pins are available, and this board is particularly designed for creating some devices which is small in size, so which will take roughly 2 to 3 centimeters space. So we can directly use this particular board for implementing small projects. So that is the advantage of this Arduino Nano board. And apart from these general boards, some other variants of Arduino are Lilypad and Redboard boards, so which are also quite used in the industry, in the market as well. So now let's talk about the accessories which are attached to your Arduino board, which will give multiple capabilities. So the thing is nothing but Arduino shields, which is mounted on top of all the boards available. So what are the Arduino shields available, and what are the general shields what we are using for multiple projects? Let's list out which are wireless shields and GSM shields, Ethernet shields, and prototype shields. So we know Arduino, general Arduino Uno board, which does not support Wi-Fi. So you can able to, and even it does not support Ethernet as well. So if you need to access, I mean, you're interfacing a number of some sensors, and if you need to try to send those to any cloud platforms, you should definitely you should need some what internet services. So either wired or wireless. If you go with the wired internet service, we call as Ethernet. So you should have Ethernet port will be available on the board. So which is not available in Arduino. So you should go for something called Ethernet Shield as the third one. And if you don't have any wired internet connection, obviously you can go with a Wi-Fi option. So again, you need a Wi-Fi module to connect your Arduino to that particular module, and you need to upload something to the cloud. So these are the different kinds of shield that is usually interfaced with Arduino for multiple purpose. So let's get into all this, and you can see that the first one which is listed here, it's nothing but Arduino Wi-Fi shield. So this is Arduino Wi-Fi shield, and which can be mounted on top of your antenna, Arduino board, and you can able to access the Wi-Fi, which is very simple. And nowadays we have one more board alternate for the Arduino, which is Node MCU. So Node MCU is same as Arduino, and which is little bit smaller as well. But this particular board can integrate both Wi-Fi as well as the existing Arduino architecture that is available as Node MCU. The only disadvantage is that the Node MCU have only one analog pin, but in Arduino you have nearly 6 analog pins are available. So you can go with that option, or else you can use the still Arduino board, and you can mount this particular Wi-Fi shield on top of your Arduino, and you can able to connect to any internet Wi-Fi services. And the second one is GSM shield. So basically, if you are working with any projects which will send a SMS as the output, so obviously you need the service of a GSM module. So you can attach this particular GSM module, that means mounted on the Arduino, and you need to code accordingly so that you can able to trigger some output through messages, the mobile messages, and that particular applications you can use this GSM module. And the third one is Ethernet shield, which is an alternative for the first option, that is getting access to internet. So here the Ethernet shield, you can see that here one port is available, RJ45. So you can able to connect your Ethernet cable to this particular port, and you need to mount the entire shield on top of your Arduino board, and you need to code accordingly so that you will get access to internet through wired connection, and you can able to push something to the cloud, so which is also possible. And the fourth one is prototype shield. Prototype shield is, you instead of you are holding something like a separate breadboard and doing connections, you can directly mount this particular prototype board on top of your Arduino, and you can create some small circuits which still have connected to your Arduino, which is possible for if you are doing some robotic applications like ultrasonics based car, or object detection car or something. You can use this. So a small interfacing circuit can be mounted on the breadboard, and which will be still connected to your Arduino board, so you can complete the project in a single board. So this is the feasibility of this particular prototype shield. Now let's get into Arduino Uno. So I'm going to tell something with the basic pin layouts of this Arduino board, and later on we get into Arduino IDE software as well. So while talking about this Arduino Uno board, so in the right side you can see that this is the basic image of your Arduino board. How this is how it look like. So on the right side, left side, you can see different parts labeled here. So let's move on to different kinds of pins are available, and what are the other components attached to this particular board. we will get some basic in depth. So now you can see that uh, in the top side a DC power jacket is available. So through this you can able to connect any adapter and you can able to power up your Arduino. To turn on your Arduino, obviously you need to give some power supplies. So if you have a 9 to 12 volt adapter, DC power supply is available. You can connect the DC power supply connector to this port, and obviously your Arduino will be turned on. So keep on telling your voltage should be between 9 to 12 volt, and if you are giving something beyond 20 volt, which will you burn the ICs or something, and your board will not be used for further processing, right? When nearby this particular DC jacket, one IC is available, which is nothing but a voltage regulator that is already implemented there. You are not going to do anything with that. And now we can see that this particular one is called USB port. So whenever you are doing any project, you will connect all the circuits. Now you are doing some coding, the logic you are written in Arduino IDE software. So after writing the codes, you will execute it, and if everything is right, now you need to upload your program to this particular Arduino board. So only for this purpose you can connect a USB port which is available while you are buying this Arduino board. A cable will be available, so that cable will be one end of the cable will be connected to the USB port, the other will be connected to the system USB port, and by choosing proper port numbers and the board name, you can able to upload the already written code to this particular board. After that you can able to start, Arduino will start working on the point when you uploaded the program. After successfully uploading the program, your Arduino start working according to the logic what you written. So for this purpose, so uploading the codes you can use this USB port. But one more thing is that if you are not using any power supplies, when you are connecting a Arduino board directly to PC through the USB port, from the USB port itself your 5 volt power supply is available, and which will power the Arduino. So straightly connecting to your PC itself, your Arduino will be powered. But if you are using some standalone application, like if you are creating a robotic car, that car should not always connected to your system, right? So that is separated from the system. So in that case you need to power it up separately. So you can use a power I mean a power bank or something through USB. You can give the power supply, or you can buy a 9 volt battery. Using a proper connector, you can give the power supply to the Arduino board. Now apart from that, you can see that the core part of this Arduino board is this particular IC. So this IC is at Mega 328P, which is the brain of this particular Arduino Uno board. So all the logic, everything will be processed by this board. So we can say that this is nothing but the brain of the Arduino board. Now let's talk something about the different pins available in the Arduino board. So according to this board, instead of without knowing all which pins are doing which function, so we cannot do anything. So let's get into these pin configurations. So in the left side we can see that nearly 8 to 10 pins are available. So we call it as power source pins. So we have some 3 volt power supply, 3.3 volt supply is available, then 5 volt supply is available, and two ground connections are available, and one V voltage in function pin is available. So all these pin can be used for getting 5 volt, 3 volt for the circuits, as well as you can, if you are requiring any ground pins, so you can use it for your circuit purpose. And now in the bottom side you can see that 0 to 5, so totally A0 to A5, so totally 6 analog pins are available. These analog pins are used to read analog values, so you can only interface analog sensors to this particular pin. So if you are using an analog sensor, obviously you require some analog pins. So when you are inserting an analog pin, the inbuilt A to D converter, that is A to D, analog to digital converter, will convert this value to digital, and this will be processed by your corresponding controller, because a microcontroller will not take analog values directly. So for that we are using A to D converters. So if you are using any other microcontroller, you should have a separate A to D converter for processing an analog sensor. So here it is dedicatedly given 0 to 5, that is totally 6 pins for analog sensor, so you can directly interface your analog sensor to the board. Apart from that, you can see that in the right side from 0 to nearly 13 digital pins are available, so which can be used as a general input output pins. So for all the digital pulse sensors, as other lightning LED and all other functions, interfacing an LCD, whatever the functions, you can use all these 13 digital pins. And here especially from 0 and 1, which is written, 0 is written as RX, that is transmitter, and 1 is written as TX, that is sorry, 0 is written as RX receiver, and 1 is written as TX transmitter. So these two pins are dedicated for some purpose, for some applications like interfacing a GPS module or interfacing an Bluetooth module. So all their while transmitter is connected to the receiver end of the module, and receiver is connected to the transmitter end of the module, so that if some device is sending something, it is sending something, so the receiver module is connected and it will receive the thing, and if you need to send something, the transmit module, through the transmitter pin you are transmitting something. So just like your mouth and ears, so mouth is your transmitter and ear is your receiver, so these two pins are used for transmitter applications like Bluetooth, Wi-Fi or Zigbee, something interface with your Arduino board. So and from 2 onwards up to 13 you can use for general input purpose. And you have one more ground is available, that is after 13th pin you can see one more ground is, you can still use this ground pin. So these are the basic pin configurations, and one reset pin is available in the top, which you need to reset whatever the code you written before. You can able to reset it by pressing once, you can able to reset the code which is already uploaded back, right? So now we will discuss about the different kind of powering your, I mean giving power supply to your Arduino board. So I already told you the voltage range that is given to the input to power of your Arduino is nothing but your 9-volt power supply. Mostly we use 9 volt, or for 9 to 12 volt DC power supply will be supported by your Arduino, so you can choose in that range for powering your Arduino board. And you should, if suppose we are using any adapter, DC adapter something, and you need to use 2.1 power plug, so that is the diameter of that particular pin that is injected to the your micro Arduino microcontroller basically. So you can see the image in the right side. So you can see here in the right side, yeah, this is one example of your adapter. So center positive, which is written as center positive, that means that adapter pin 2.1 pin, the center part should be your positive and the outer layer should be your negative. That's how it is connected, and most of the adapter which is following this universal rule. So you can use this kind of adapter to power up your Arduino, and this particular pin will be connected to this particular power jacket, and if you turn on the switch your Arduino will be turned on. And one of suppose I told you, if you are not connected your Arduino board to, I mean it is not standalone, suppose you are creating an robotic car or something, then the device will be moving around, so you cannot use a wired connection to power up your Arduino. In that case you can able to use a battery, as the third diagram indicates. A 9 volt DC battery is available, so you can use this connector and directly connect it to these pins, so that you can able to power it up, or you can able to buy a 2.1 adapter, sorry, socket like this, and connect your battery terminals to this particular socket, and that can be inserted into this power jacket. In this method, actually that is displayed in the fourth diagram. So battery is there, 9 volt battery is there, and in that battery you can see that this particular 2.0 jacket is connected to the battery, and that is inserted into the Arduino power jacket, and your Arduino will be powered up. So these are the multiple methods to power up your Arduino board. So yeah, this reflects many things. So the thing is that the hardware platform, your Arduino board, so this is your Arduino board, Uno board, and this is nothing but your Arduino IDE software. So if you have both, you have a powerful board and you have a coding platform, then you can play. It's nothing but your playground. You can play around, and you can able to make many things. You can automate anything around you. So try to do something learning these two things, right? Okay, so I told you what are the pin configurations, how you power up your Arduino boards and all the stuff. So I think your hardware side, that is fine. Now let's get into your software side. So I'm introducing Arduino IDE software, that is open source as well. You can able to download it, and the link is given here, http www.arduino.cc. That is official sites of Arduino. So you can go there, and download tab is there. You can download it according to the operating system you are using. For Windows 7 and XP, or Windows 10 latest version you are using, according to your platform, even if you are using Linux or Mac operating systems. So based upon the platform, you have separate download options are available. So download the software, install it in your system, and after installing, you will get an Arduino simple in the desktop. A shortcut will be created. So double clicking, you will open that particular software, Arduino IDE software, and this is nothing but the interface. When you open the software, this is the interface you are getting initially. So let me tell you what are the different options available, and so that you can able to code it very easily. So before that, let me tell you what are the advantages of this particular software. So this Arduino is basically told you programmed in basical C programming. So the language is very simple and provide many abstraction for the simplicity of reading, writing powerful applications. So which is very much advantage for basically for a startup like students. So it provides a serial monitor to see the serial data from the USB through a virtual comport. So for example, suppose I am interfacing something, suppose I am interfacing a temperature sensor to your Arduino board, and I am writing some code to detect the temperature, current temperature, and I'm uploading the code to the Arduino board. So when the program is written into the Arduino, for the next second, your Arduino start sensing the temperature through the temperature sensor. And how can you see the output? So this the output can be seen through the right side. You have a lens like magnifier, a lens like symbol is available in the right top corner. So clicking on this particular simple, you can able to see the outputs, the corresponding second by second, based upon the delay you given, the corresponding second by second temperature, what is sensed by your temperature sensor, can be seen through your serial port. So why it is called serial port means, through the serial communication it is getting the data, so we call it a serial port. And this so here so one second. Yeah, here you can see first one, a small tick like structure is there. So if you are writing something, some code here available in the dashboard, so you are writing some codes, and if you click on this first tick button, which is used for verify, so you are checking that whether the code is correct or not, logically correct or not. If any mistakes in the code, you are using that verify button. And once you are getting verified successfully, because there is no bugs or error in the code, now you need to click on next button, arrow button, that is called upload button. So upload button is used to upload your verified code to your Arduino board, so which is used for uploading your code. And when you have open button, save button, basic operations all. And one more thing, that whenever you are writing something, I will give you a separate programming session for Arduino, and that will be in your later stage, because initially we are using Tinkercad software to do some experiments, basic experiments like interfacing an LED, blinking of LED, then we are interfacing an LCD board, and later on we use some small sensors like LM35, say temperature sensor, then humidity sensor, and then some servo, rotating some servo motor applications, then some ultrasonic sensor applications. So, and we are using Tinkercad. We are focusing on Tinkercad. This is because Tinkercad support block coding. So instead of writing code, you can drag and drop some blocks, and that blocks will create codes in the background, so which is very easy. If the people don't have any kind of programming skill, they can do it very easily, and then it will automatically generate code in the background that will be uploaded to the board, and you can do your experiments. So that is the first thing. And later on we will go directly into Arduino, because if you are doing some bigger projects and you are from beginner you migrated to intermediate stage, then obviously instead of this kind of block codes, you are going to program it directly through Arduino IDE softwares. So in that time you need some basic stuff on this particular platform. So we'll give you a separate lecture on a tutorial on how to do coding in Arduino IDE as well. So steps in coding in Arduino IDE. So just open your Arduino IDE, then we will write some code. So you have void setup and void loop is available. Void setup, you are declaring all the functions, and in the void loop you are writing your logic, and it will execute infinitely. So this is how it works. And click verify button. So you need to verify whether the code is correct or not, and after compiling and you are getting successfully verified and compiled, then you can able to upload your code to your particular Arduino board using upload button. Now you before uploading you need to attach your Arduino to your PC through the USB cable, and you need to select the proper communication port, that is COM port. So that you can see from the device manager. I will show you later. So suppose your Arduino is connected to COM port 3, you need to choose the COM port 3, that is communication port 3, so that the proper data transfer will be possible. And later on you need to choose the corresponding board. For example, I am attached my Arduino Uno board to the system, so accordingly you need to choose Arduino Uno board in the IDE software as well, because different flavors of Arduino board is available in the market, and each and every board have different architectures. So if you are writing some code for Arduino Uno, and if you are trying to upload this particular code to Arduino Mega board, so the architecture is different, so which will not support that logic. So you need to choose accordingly, and after uploading your board start working according to the logic what you written. And I hope you got a rough idea about Arduino as well as basic Arduino IDE software. I think this is enough to start something on this particular platform. And one of the question frequently asked by most of the students are, why Arduino, right? So in the industry, yes, of course, you are getting some n number of boards. Basically, ARM boards are there, which is basically a brilliant architecture, highly efficient, and low power consumption. Yeah, and Texas boards are available, and now Raspberry Pi is available. So why Arduino? So the reason is that in order to start and simple projects from a school age, whether you are in an engineering student, you need to kickstart something, then I can say that Arduino is the best platform to start something, because the kind of interface which is provided in the software as well as your hardware part is very simple. A layman can understand and can able to do something just browsing your internet. But if you are get into Raspberry Pi, of course, even a 10th student cannot do it, because when you need to power up your Raspberry Pi itself, some kind of hard task is there to write the operating system to the particular SD card. You need to boot up, and if you're doing something you need to know Python. So, and obviously the operating system is Linux as well. So how many of you are using Linux operating system? So which is very much difficult for someone from schooling and all, right? And now I think in engineering college also it tough because everybody is using either Mac or Windows. Your GUI is just like mouse and keyboard, right? But Linux is something you are doing more in terminals. So that is one problem. And if you are going with some other boards like ARM board, different ARM boards are available, greater upgradations are there. And I can say that industry, they are not at all using your Arduino, because when they are from the prototype, if somebody is going to an application oriented a product, then obviously they converted to ARM based controllers, because those are the controllers and processors which is used in the industries. So basically, if you are creating a prototype, so obviously you can use Arduino, and which is very easy. I think you can code it very easily. A lot of tutorials are available. We are going to post continuous tutorials on this particular domain, so you can able to create multiple projects and get the basics, and you can do yourself according to your idea. So I think, I hope you have gotten basics on Arduino IDE as well as this particular board. So stay tuned. We will upload the next video on Tinkercad as well. So you are getting step-by-step tutorials on how to use Tinkercad and how to code without typing it, just using block codes. And we are giving a number of experiments as well. So after completing this particular course, you can say that you can able to create your own product as well. So stay tuned.